Welcome to this video tutorial. In this video, we are looking at real number system. And before we move on to the major components of real number system, let us look at three key concepts of real number system. And in this, the three concepts we are looking at they are natural numbers, whole numbers, and integers. Now, the first major component or the first key concept is natural numbers. And per what we have here, they are set of positive or non-negative numbers used for counting and ordering. They start at 1 and continue indefinitely. So let's look at explanation to this definition. So we said they are set of positive numbers. So it means natural numbers are not negative numbers. They are always positive numbers. And they are used for counting. So that's one of the major uses, and also for ordering. Now let's look at for the counting first. Now we all know counting. Counting, we can talk about the number of students in the class, the number of teachers in the school, the number of exercise books in your bag, the number of pens you have. So that's a counting. And also for ordering. Ordering, we can talk about, or we can relate it to maybe the positions of students after exams or class tests. So we can say Eric is number 1 per the marks obtained in maybe in mathematics examination. Maybe Kwesi is number 2 or second, is in the second position. Ama is in the third position. Ajua the fourth position. So their positions are assigned with numbers. So Kwesi is number 1, Kofi number 2, Ama number 3, Ajua number 4. So we can use counting numbers or natural numbers to order a certain group of items, or to categorize them into their various positions. Now we said that we use the symbol here N to represent natural numbers or counting numbers. So if we use the symbol N to represent natural numbers or counting numbers, it means N here is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So from our definition, we said that they start at 1 and continue indefinitely. So these 3 dots here, we call it ellipses. The ellipses, it means there are a lot of numbers to be written, but we cannot write everything. So it continues forever. That is what it means. Now let's look at visual representation of natural numbers on a number line. So on this number line, we can see that the number that starts from the left as we move to the right side is 1, followed by 2, 3, 4, 5, 6, 7, 8, 9. So from this number line, the first number on it is 1. This is to show that natural number starts from 1 and continues forever. And this arrow here, as it points towards the right side, it means there are a lot of numbers to be written. And so that is also mean the same as the ellipsis. Now let's look at why natural numbers start from 1, or why natural numbers start at 1. So let's read what is here. It says that natural numbers typically start at 1 because they were originally developed from counting physical objects. So if you want to count a physical object, you start from 1. But then if you have nothing to count, assuming uh, my hands are empty and somebody asks me, how many books do you have in your hand? There are no books there. So I can't count anything. But the moment there are some books, like, okay, I have one, two, three. Then I can tell the person that I have three books. But if I have nothing in my hand to show, if there are no physical objects to show that these are the objects, I mean, there's nothing to count. So we say that natural numbers typically start at one because they were originally developed from or for counting physical objects. So if there are no physical objects to be counted, there's nothing to count. So people did not see the need to count nothing. To count nothing. Yes. So counting begins when the first item is present. So a human naturally begins counting with one when identifying the first item in a group. So say that natural numbers only count things that exist. So natural numbers, if you want to count, if there are something or that there are items presented or physical object presented like this, then you can start counting one, two, three. So if there are no physical objects, or if there exists no object to count, there's nothing to count. There's nothing to count. So this is the reason why natural numbers starts at one. Now let's look at example of natural numbers in everyday life. We've already talked about it from the definition. So we made mention of two major uses of counting numbers. The first one is for counting items and also for ordering of items. So you have 5 tomatoes. In fact, if there are no tomatoes to be counted, you cannot even see the number of tomatoes you have at your disposal. But the moment there are tomatoes, you can just count them by starting from 1. So basically, counting numbers, let's go back to say that natural numbers only starts or natural numbers only count things that exist. So if there's nothing to be counted, there's no need to count nothing. So that is one use of natural numbers or counting numbers. Now the second use of counting numbers is for ordering. So your Bible is number 2 on the list of books. So I have some books here, and they said the Bible is number 2 on the list of books. So these are 3 books I have here. Whether you start from the bottom or whether you start from the top, you see the Bible being the number 2 on the list. So this is my Christian Asonjum, the Methodist hymn, the Fancy version, number 1. And this is the Bible, what is the number 2 on the list. And this is my diary. And so if you are asked to order items, then that is the concept from natural numbers. So maybe you have 3 or 4, drawer, and from counting from maybe your left, and your teacher asks you to go and pick the textbook from the second drawer from your left. It means the first one on the left becomes 1 followed by 2. So you just go and draw or pull that drawer and you see the textbook in that drawer. So we can use natural numbers to order items. And also we can talk about positioning of students after they have written examination. I think we've already talked about it. So we can talk about maybe Kojo is first, Ama is second, Kwesi is third, Yao is fourth, based on their performances. So we just assign the numbers to them for their arrangements. So that is another use of, natural numbers. Now let's look at the second key concept of real number system, which is whole numbers. So we said whole numbers include all natural numbers plus zero. They include natural numbers plus zero. This set represents the numbers we use for counting as well as indicating the absence of quantity. I want us to take it again. Whole numbers include all natural numbers. So whole numbers include natural numbers plus zero. Now let's look at the next line of after this sentence. See that this set represents numbers we use for counting. So numbers we use for counting, let me underline this. Numbers we use for counting is what? Natural numbers. As well as indicating the absence of quantity. So in the absence of quantity is zero. In the absence of any quantity in zero. So remember we said that natural numbers, let's go back and see. We said that natural numbers only count things that exist. Natural numbers count things that exist. So in natural numbers, if there's nothing in existence, we don't count anything. But for whole numbers, we say that this set represents numbers we use for counting as a natural numbers, as well as indicating the absence of quantity. So whole numbers accept the absence of quantity. So if there's nothing to count, whole numbers take it as one of its, quantities or one of its elements. So it indicates the absence of quantity. It indicates the absence of quantity. So whole numbers start from 0, 1, 2, 3 up to infinity. So we need to know that. So over here we can say that the differences between one of the difference between whole numbers and natural numbers is that natural numbers natural numbers only count things that exist. So if there are some items, then natural numbers will come in starting from 1. But for whole numbers, even if there's absence of quantity, whole number is interested in that. So in the absence of any quantity, that is where the 0 comes in and it becomes part of whole numbers. So from the definition, we said that whole numbers include all natural numbers plus 0. Plus 0. So that is whole numbers. Now let's look at visual representation of whole numbers. So we consider a number line that starts at 0 and continue to the right indefinitely. This line represents whole numbers, showing that they include 0. So this is the explanation we have already given, that from the number line here, we can see the first number on it to be 0. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So this set of numbers here represents our natural or our counting numbers. Then the moment we include 0, then they become what? Whole numbers. So we defined whole numbers as natural numbers plus 0. Then that will be our whole numbers. Now let's look at why whole numbers even start at zero. Already we have given some definition or explanation to that, but for easy understanding of what we are doing, let's also look at why whole number starts at zero. In fact, we have a number of reasons that shows that or that proves that whole numbers start at zero. But for the sake of time, let's look at one of them, what is called the concept of set theory. A concept of set theory. Now, in set theory, a number represents the size or the cardinality of a set. So in set theory, a number represents the size or the cardinality of a set. Now, when we talk of cardinality, it means the number of elements in a given set. The number of elements. So let's say you can have a set P given, let's say 3, 4, 7, 10. So when we talk of cardinality of this set, it means the number of elements in a set P, and we have 4. So that's the meaning of cardinality, the number of elements in the set P. Now, in set theory, we consider the empty set as one of the subsets of any given set. Example, A is a set of even numbers from 2 to 6. So for here, we are not saying that even numbers is from 2 to 6, but we are given a range, or we just want to represent those numbers to the set A. So over here, we say that A is a set of even numbers from 2 to 6. So let's list the set A. So set A, what is even numbers from 2 to 6? So we have 2, 4, 6. Now this element of set A has the following subsets. So we have 2. 2 is part of the elements in set A. We have 4 there. We have 6. We can also combine 2 and 4, 4 and 6, 2 and 6 as well. And then all of them, 2, 4, 6, is also part of the subsets, as you can see it here. Now we have the last one, which is empty set. Now remember, we said that whole numbers, let's go back and then we look at something here. We said that this set represents the numbers we use for counting, as well as indicating the absence of quantity. So it means when there is absence of quantity, that becomes zero. There's nothing there. There's no number. There's no physical object. It means whole numbers are accepted as zero. I hope you are getting it. So the empty set which has no element is considered as zero. So whole numbers include zero, which is crucial for indicating none or empty. So this is one of the reasons whole numbers starts at zero. Now let's look at the last key concept of real number system, which is integers. And we define integers as natural numbers and their negatives, including 0. Natural numbers and their negatives, including 0. So let's see, we have combined two things here: natural numbers and their negative, which is 1, and including 0. Now, integers are represented by the symbol Z. So this is the symbol representing integers. So integers are necessary when direction or value matters relative to a baseline. So example of integers in a real life situation, we can talk about the temperature of a body, so or of any other substance. So the temperature of a man can go higher, and if your temperature falls below zero, it means you are pointing towards to the negative side. And these are all real life situations of integers. Now let's look at the key components of integers. So we define from our integers that integers are natural numbers and they are negatives, including zero. So these are three things we want to look at under integers. So natural numbers, we know natural numbers already, that they start at 1 and continues indefinitely. So this is the natural number part of integer: 1, 2, 3, and you have your ellipses, and also they are negatives. So this one here, its negative is the 1 is -1, the 2 its negative is -2, and a 3 -3. Now this 3 dots before the -3 shows that there are a lot of negatives before the 3. So it is also indicating indefinite set of integers. Now the last one, including 0. So the 0 is also part of integers. So let's use the number line here to show the integer as one of the key concepts of real numbers. So from our definition, we said that they are natural numbers and they are negatives, including 0. So natural numbers, as we have here, we have 1, 2, 3, 4, 5, 6, 7, and this arrow indicates we have a lot of natural numbers to be counted. So let's look at negative of 1. So 1 has it negative, -1, 2, -2, 3, -3, 4, -4, 5, -5, 6, -6, 7, -7. In fact, you can have 8 and -8, 9, -9, 10, -10. So these are natural numbers and they are negatives, including 0, here. So now let's look at these natural numbers, whole numbers, and integers. So we've already talked about each of them. So natural numbers, we have 1, 2, 3, 4, 5, 6 up to infinity. Whole numbers 0, 1, 2, 3, 4, 5, 6 up to infinity. And then integers. So we said natural numbers and they are negatives, including 0. So 1, -1, 2, -2, 3, -3, 4, 5, and you may have their negatives as well, including 0. So natural numbers are subsets of whole numbers. So we want to look at how natural numbers and whole numbers relate. So we can see that natural numbers can be found inside whole numbers. So we say that natural numbers are subsets. So we use the symbol here, this to represent. So the one on the left side becomes a subset to the one on the right side. So natural numbers are subsets of whole numbers. It means natural numbers can be found inside whole numbers. Let's also look at integers. So integers, we've already talked about them. So we say that natural numbers are subset of whole numbers, as we have already explained, and whole numbers are also subset of integers. So it means these whole numbers here, this whole number 0, 1, 2, 3, 4 can also be found inside the integers. it means whole numbers are subsets of integers. It means whole numbers can be found inside integers. So based on these three key concepts, one, natural numbers can be found inside whole numbers, and whole numbers can also be found inside integers. So it means natural numbers and whole numbers are all subsets, meaning natural numbers and whole numbers are all inside, or they can be found inside integers. So let's read the last one. Say that therefore natural numbers and whole numbers are all subsets of integers. It means both natural numbers and whole numbers can be found inside integers. Good. Now this diagram or two diagrams here gives more explanation to what we have already discussed, the relations among natural numbers, whole numbers, and integers. So natural numbers are subsets of whole numbers, and whole numbers are also subsets of integers. It means both whole numbers and natural numbers are all subsets of integers. So let's look at these circles here. Now the bigger circle here is the integer or integers, integers, and then inside the integer we can find whole numbers, and then inside the whole numbers we can also find, or we can also see, natural numbers. So natural numbers are found inside whole numbers are found inside integers, and both natural numbers and whole numbers are all found inside integers. Now this second diagram also here gives better explanation to that. So we have natural numbers, whole numbers, and integers. So natural numbers starting from 1, 2, 3, 4, 5, 6, 7, 8 in this, whole numbers including 0. So when we add 0 to natural numbers, then we have the whole numbers. And then natural numbers, they are negative. So 1, -1, 2, -2, 3, -3, 4, -4, 5, -5, 6, -6, 7, -7, and 8, -8, including 0, are all found inside integers. And for that reason, we can say that natural numbers, whole numbers are all subsets of integers. So this is the relations among the three key concepts of real number system.